Hi, it's Christian again with screencast number 7. In this example, we were given that two people are pushing in opposite directions on a crate that's on a frictionless surface, but somehow the crate ends up moving from point A to point B to the left, but the crate does not rotate. And then we were asked to compare or to find the work that each person does on the crate. And again, we weren't given any numerical values or any like math, anything like that remotely similar that we could possibly find them. So I just used um, Newton's second law and tried to apply the expressions the best I could and try to explain why. Um, so since both people are pushing in opposite directions, the tension is the same for both people. They're both pushing with the same force. And I know that work is equal to the force times the distance, and they each move the same distance, but each person does in different directions because obviously the crate moved to the left, so then that just means that each person did the same amount of work, but one person did negative work and the other did positive work because one person was pushing away from the motion that the crate eventually moved and then came to a rest. And then the second part, we were given an example that if we were climbing on a rope hanging from the ceiling, what would be the work of gravity on us? And you can simply find the work of gravity by using WC equals mgh, which is the height. But again, they didn't give us any height, any mass, any of that. So I just went ahead and used my own weight here and tried to find my mass, but that really doesn't help at all because of the height. Height would be some constant, I'm guessing, at that point. And but since gravity, the work of gravity has to do with things being pushed or pulled towards the earth, and since in this case you're climbing up the rope and you're going away from the earth, the work of gravity in this case is negative because it's in the opposite direction. And then we were asked also to find the work that the rope does on us. So the rope can, in this case, act kind of like a spring, but we were given that the rope does not compress or stretch as we are climbing it, so it does not move. So it is at equilibrium. And then you can find the work of a spring by using this formula here, but the x is 0 because the rope does not uh, expand at all. So then that just means that the work that the rope does on us equals 0.